See, now let us see the Gibbs energy change and equilibrium. See, we know the one basic thing that we have there were basically three questions after the first law of thermodynamics that which we were not able to answer from the first law. The first one was the conditions of spontaneity, which we have got the answer in terms of free energy, and the second were the extent of completion of reaction and the direction of reaction. See, we get the answers of these two questions from this relationship. Let us take an example of a reaction in which A moles of A combines with B moles of B, giving you the C moles of C and D moles of D. The reaction is at equilibrium. See, we need to know that delta G is equal to delta G naught plus 2.303 RT log Q. See, this is the equation which we get from the third law of thermodynamics, which gives us the formula of finding out the free energy under non-STP conditions, which is equal to the free energy change at standard conditions plus 2.303 RT log Q. Here this Q is your reaction quotient, which you will be doing in your equilibrium chapter, or you must have done in your equilibrium chapter. Now we know that at equilibrium, this delta G is equal to 0. So it means what? This delta G naught is equal to, and remember Q is equal to your K equilibrium. So delta G naught becomes minus 2.303 RT log K equilibrium. So this is how we can have this expression, which is very, very important, and from here delta G naught's value we can easily make out that if this is negative, this is negative, negative, this is negative, the process is spontaneous. Remember, this is negative, this gets cancelled, so the value of your equilibrium constant will be positive, and we know that once this value is positive, is more than one, we know that the process is spontaneous, the equilibrium is towards the product side, it is leading to the what? Completion. But whereas if this is positive and this is negative, remember your K equilibrium will become negative, it will be less than 1. So it means what? The value is, the equilibrium constant is towards reactant side, that means such reactions are not proceeding. So we can easily relate equilibrium and thermodynamics from this formula, and this is the formula which gives us a clear-cut idea that from here we can find out the direction and the extent of completion of reaction.